Okay, so good afternoon to all. And today, as already told, here we are going to start the unit number 5, that is steam nozzle. So this unit, anybody of you can define steam nozzle? Up till now, anybody of you have idea about steam nozzle? Anybody? What do you mean by steam nozzle? Nozzle means what? No idea. Nozzle. No, nobody is having idea about nozzle. Steam nozzle. A simple nozzle. Whatever the nozzle is there, maybe it may be water nozzle is there or simple nozzle. Anybody having idea what is meant by nozzle? So nobody define it. Asmita, Prerna, today, Jagannatha Vatade. Anybody of you? Abhishek Yadav. Okay. Control direction of flow. Asmita. No. Control direction of flow. No, it is not that nozzle. So nozzle is the device. Now I will define. Somebody is defining. It is used to transfer kinetic energy. Prerna is correct, not transfer kinetic energy. Okay, it is not transfer kinetic. Okay, transfer kinetic. It is used to generate kinetic energy, not transfer. Transfer is also there, but it is used to generate the kinetic energy. So nozzle is a device where we are increasing the velocity. That is, velocity means kinetic energy of the steam. Okay, so whatever the steam we are getting from boiler, what is the steam we are getting from the boiler, it is having, whatever steam we are getting from the boiler, it is having here. If it is boiler, so this steam we are supply getting, and this steam is having high pressure. So pressure is high, pressure will be very high. In this case, it is having enthalpy, we can say it H, specific enthalpy, heat content or thermal energy is too high, is also very high. Okay, Abhishek are very defined. The cross section of nozzle first decreases from its entrance to the throat and then increases from its throat. But okay, it is the construction. So pressure is more, enthalpy is more, means thermal energy is more of the steam, whatever the steam we are getting from the boiler, and this steam we are impacting on the blades of the turbine. Okay, and this turbine is used to do expansion purpose. So, and we are generating the work. Okay, so whatever this particular, okay, so the steam is generating. So whatever the steam, if thermal energy is there, high thermal energy. So this thermal energy, device which converts thermal energy of steam into kinetic energy by increasing velocity, by decreasing pressure. So if you decrease the pressure, definitely here and expansion is going to be taking place. So whatever actual expansion of the steam is taking place, it is taking place in the nozzle, and afterwards, where the after nozzle we are discussing only about the kinetic energy of the steam, but up to nozzle we are discussing about the thermal energy of the steam, and this thermal energy is converted into kinetic energy. That is, velocity of that particular steam is increased in the nozzle. So that element is called as, that element of the steam turbine is called as steam nozzle. Everybody knowing or note down steam nozzle. So steam nozzle, it is a device which converts thermal energy of steam into kinetic energy of steam by increasing velocity of flow. That is as usual. So obviously is there. So by increasing, as kinetic energy is defined as 1/2 mv square. If it is specific kinetic enthalpy we are discussing, specific mass means 1/2 mv square, or now in this case chapter C, we were replacing by C. So if mass is equal to specific volume, means mass is equal to m. is equal to 1 kg. If we are considering specific mass, then kinetic energy will be equal to what? V square divided by 2. So this will be the kinetic energy. So to velocity we are increasing by decreasing the pressure. So that device we are calling as a steam nozzle. So note down, it is a device which converts thermal energy of steam into kinetic energy of steam by increasing, means obvious, by increasing velocity of flow. So thermal energy means what? How we are decreasing thermal energy? Thermal energy we can decrease by following way. So it is the expansion where taking place. So by decreasing the pressure is decreasing, or enthalpy is decreasing, means expansion is taking place in the nozzle. So device in which the expansion is taking place, so that device we call it as a here steam nozzle. Everybody understand steam nozzle? Basic of steam nozzle, everybody understand? Please reply in chat box. Okay, Asmita understood. Others please reply. Abhishek, you are correct, but it is okay. So it is not exact definition. Prerna and is also get understanding. Others please reply. Abhishek Zalo, yes, sir, understood. Okay. Others please reply. So now there are three types of nozzles. So kinetic energy. So we are discussing about how thermal energy is converting into kinetic energy. So henceforth we are discussing about the output of the nozzle is always kinetic energy or velocity energy, we say. So steam nozzle, there are three types of nozzles. Okay. So okay, now instead of here going to, we'll go simultaneously some other presentation also. Okay. So here also one. Okay. Is this screen visible? New slide is visible. Yes. Okay. So here a steam nozzle. A steam nozzle may be defined as passage of varying cross sections through which heat energy of steam is converting into kinetic energy. Steam nozzle major function is to produce steam jet. Steam jet means what? You are increasing the kinetic energy. So steam jet means what? Here it is increasing the kinetic energy. Jet means velocity with very high velocity. With high velocity to drive the steam turbines. Okay, so this is a steam jet with very high velocity to drive the steam turbines. And the shape of the nozzle is designed such a way that it will perform this conversion of energy with minimum losses. So losses should be as minimum losses. Okay, so steam nozzle. Now the energy conversion is brought about in the following ways. So how we are through pressure we are decreasing. I told you the high pressure, high temperature steam first expands in the nozzle. So whatever the nozzle expansion we are taking place, so this expansion is taking place in the nozzle only. So expansion, the high steam pressure, high temperature steam first expands in the nozzle, emanates as a high velocity of the fluid. Okay, so first of all, whatever the expansion we are discussing about in the turbine, isentropic expansion. So this isentropic expansion actually takes place in the nozzle only. Then the high velocity steam coming out from the nozzles impinges on the blades mounted on the wheel. So afterwards, it is the here this high velocity, high kinetic energy steam is expanding on the blades of the turbine. Impinging is here it is bombarded on the blades of the turbine, and afterwards the high velocity steam is impacted coming out of the nozzles, impinges on the blades mounted on the wheel, and therefore these wheels blades will rotate. As these blades are, the fluid steam suffers a loss of momentum, so the steam's velocity is given to the blade, and blade's velocity will get increases. and this blade will rotate, and these blades are connected with this particular shaft. Okay, therefore the wheel will also rotate as the shaft is rotating. So while flowing past blades that is absorbed by the rotating wheel, enabling production of torque. So torque means displacement. If anything is displaced, we can produce the torque. So first of all, what will happen? The change of momentum is nothing but it's producing the force or torque, and force into momentum, that is distance, is equal to torque. So the moving blades move as a result of the impulse of steam caused by the change of momentum, and also as a result of the expansion and acceleration of steam. So here the steam turbines will follow after in the chapter steam turbine. We are going to see the details. Okay, so F is equal to ma. So it is following the law. Resultant law is equal to F is equal to m into a. As the acceleration in that direction increases, resultant force will also increases. So this is nothing but acceleration means blade acceleration. Blade get accelerated, and steam is retarded means it is giving its momentum to the blade, and change of momentum is nothing but what? Rate of change of momentum is nothing but force will be exerted on the blade, and it is displaces with some movement, and that distance of force into that perpendicular distance is nothing but torque. We are getting the torque from this particular turbine. So working of steam nozzle. So during the first part of the nozzle, the steam increases its velocity, and then so it is. After we are going to discuss in detail. So during the first part of the nozzle, the steam increases its velocity, and later part of the nozzle, in which steam derives more in volume than the velocity. So next part is the divergent part. So afterwards we are going to in detail. Mass flow rate of steam remains constant. So this we have to understand throughout the chapter. So since here mass of the steam which is passed through any section of the steam remains constant. So mass flow rate of the steam remains constant. Pressure is get variation in pressure. So pressure of the steam, the variation of steam pressure in the nozzle depends on the velocity, specific volume, and dryness fraction of steam. Okay, so pressure is goes on decreasing, and how much pressure is decreasing? First slide is visible. Okay. Now the second slide is visible. Okay, now it is visible. Okay, so I will repeat from first. Okay, so again I will repeat. So energy conversion is brought about in following ways. How we are bringing the energy conversion? So first of all, the high pressure, high temperature steam first expands in the nozzle and emanates as a high velocity fluid stream. Okay, then high velocity steam coming out nozzle impinges on the blades mounted on a wheel. The fluid stream suffers a loss of momentum while flowing past the blades, that is absorbed by rotating wheel, entailing the production of torque. So I told you that steam is losing its velocity, and it is giving to the blades, and these blades are mounted on a wheel. So these blades will rotate, and therefore the wheel will rotate, and the wheel is connected to the shaft. Shaft will rotate. So shaft will rotate means we are developing the mechanical energy. So steam turbines are the devices which converts kinetic energy of the steam into mechanical energy. Okay, so the fluids and the nozzle is a device which converts thermal energy of the steam into kinetic energy. The fluid stream suffers a loss of momentum, means steam loses momentum, and it is gained by the blades, and blades will give that momentum to the wheel will give to the shaft, and the shaft will rotate. And if the shaft is rotated in the presence of magnetic field, EMF, electromotive force, is developed. So that is the how electricity generated. That is the next part. The moving blade moves as a result of the impulse of steam caused by the change of moment. So steam's momentum is lost and it is gained by the blade. Also, as a result of expansion and acceleration of the steam related to them. In other words, they are also act as a nozzles. Moving blades will be also act as a nozzle. So steam nozzles working. So since during the first part, steam increases its velocity, and then afterwards, it it will derive or it will gain the volume, because volume is also very much important. So mass flow rate of the steam is remaining constant. Okay, remember that mass flow rate, if it is depending on the contained equation, mass flow rate of the steam remains constant. Okay, and the variation of steam pressure in nozzle depends on the velocity, specific volume, and dryness fraction. So how much pressure is decreasing? So it is decreasing and depends on the velocity. So how much expansion we are carrying out in nozzle, depending on that, velocity will increase. The main use of steam nozzle in steam turbine is to produce jet. Jet means high velocity. Jet is referred as high velocity. Jet means what? It is referred for high velocity. I have told already, high velocity. Jet means high velocity. So to produce steam, so up till now understand only that steam nozzles are the devices which uses to generate the jet or high velocity of that particular steam. Okay, the smallest section of the nozzle is called as throat. So afterwards we are going to discuss that part. So how, where up till now understood? Now visible everything? Please reply. Yes, understood. Okay, visible, Smita? All slides are visible. Whatever now continuation slides are running. Okay. So applications of steam nozzles are the, what is that? It is used in steam and gas turbines and jet engines where we want to use more velocity, in rocket motors where we can use this particular steam nozzle. It is used to measure discharge of fluid, for example, intermeter. Okay. Then injectors. Supersonic means what? Supersonic means to generate the to rotate the gas turbines with more than velocity of sound. It is supersonic. Okay. Then rockets for providing sufficient thrust to move upwards. So these nozzles are used for removing air from the condenser using the injector. Spray painting. So this is the application of spray painting also. Steam jet refrigerant system where we can get refrigeration with the help of steam. Now we are going to discuss the types of nozzles. So write down your heading. So up till now, some part I am getting somewhat practical knowledge. So this is very important. Types of nozzles. Okay. So types of nozzles. There are 3 types of nozzles. Write down types of nozzle. 3 types of nozzle. One is, anybody? This is convergent nozzle. Another is divergent nozzle. And third part is nothing but convergent divergent nozzle. So draw this also. Types of nozzles. I will give 3 to 4 minutes to you. So till that, draw types of nozzles, write down convergent nozzle, divergent nozzle, and third one is convergent divergent nozzle. Or otherwise, I will explain first and then we'll go to this. So convergent nozzle, what is convergent nozzle? The cross-sectional area of this nozzle goes on decreasing towards outlet. So if we consider this as a, see, we are considering as a inlet. So part 1 is acting as an inlet where steam is entering, and from part 2 the steam is coming out as an exit. So we can call it as an outlet. Okay. So what we can say, or in entry to exit we can say. Okay. So okay. So here the cross sectional area or passage area, this is passage we can say, cross sectional area of the steam goes on decreasing towards outlet. So that type of nozzle is called as convergent nozzle. Okay. And divergent nozzle means what? The cross sectional area of the nozzle goes on increasing towards outlet. So that type of nozzle is called as divergent nozzle. Another type of nozzle is what? Convergent divergent. It is a shear mix. It is combination of convergent divergent. It is called as convergent divergent nozzle. So first of all, the inlet to one section, third section we are considering. So up to third section. area is goes on decreasing towards center, and afterward from the third section to outlet it is also goes on increasing. So this will be acting as convergent portion. This is convergent and this is divergent. And where the area of that nozzle is minimum, so that third section is called as throat of the nozzle. It is called what? Throat, where the cross section area is very much minimum. Okay, so everybody got this? So this is convergent nozzle, divergent nozzle, and convergent divergent nozzle. So another part is convergent divergent nozzle. So you have everybody to write this. A typical convergent nozzle is shown in figure. In a convergent nozzle, cross-sectional area decreases continuously from its entrance to exit, inlet to outlet or entrance to exit. It is usually in a case where back pressure is equal to or greater than critical pressure ratio. So now critical pressure ratio, we have to, now we are going for critical pressure ratio is what? The pressure ratio which gives maximum mass flow rate. So critical pressure ratio means what? It is a pressure ratio is outlet pressure divided by inlet pressure. Let us consider throat pressure, out pressure, where the velocity is minimum, their pressure is maximum. So here will be P2 upon P1. It is called as throat pressure to inlet pressure. It is called as critical pressure. So where is the throat? So where the area is minimum, that we call it as a throat. Okay, and that pressure ratio, throat P2 upon P1, that pressure ratio is called as critical pressure ratio, and which gives maximum mass flow rate. It gives what? Maximum mass flow rate. So the pressure ratio which gives maximum mass flow rate of nozzle, that pressure ratio is called as critical pressure ratio, mass flow rate. Okay, so write down in your notebook also critical pressure rate, because this term we are going to use many times. So critical pressure ratio is what? The pressure ratio which gives maximum mass flow rate through the nozzle is called as critical pressure ratio. Okay, and when the critical pressure ratio or back pressure is equal or greater than the critical pressure, back pressure means P2, outlet pressure, if it is greater than or equal to critical pressure ratio, then we have to use this convergent nozzle. We have to calculate afterwards. Okay, divergent, it is exactly opposite to that. The cross sectional area of divergent nozzle increases continuously from entrance to exit. It is used when where the back pressure is less than the critical pressure ratio. Back pressure is less than the critical pressure ratio. So generally divergent nozzles are not used here. Maximally convergent nozzle or convergent divergent nozzles are used frequently. So convergent nozzle in this case, cross section area first decreases from entrance to throat. Throat, this is called a third section is called a throat, and then increases from throat to exit. It is widely used in many types of the steam turbines. So maximum all turbines we are going to use this combination. It is convergent divergent nozzle. Okay. So everybody understand this convergent nozzle up till now? Types of nozzles understood by everybody? Please reply. I want to reply from everybody because this is basic. Asmita only understanding, others please reply. Jagannath, yes sir. Thank you Jagannath for replying. Ganesh Gowri, yes sir. Okay, now I request everybody to draw these figures. I will give 5 minutes to you. Convergent, then afterwards they make an explanation like this: convergent nozzle figure and then explanation. So I will give some time to you. So draw these diagrams, and this, because this is very important. I am giving this here, but still that you write down this. Draw the figures. I give 5 minutes to you. Please draw and afterwards tell me over. All things are very much important. Write down where convergent nozzles are used, when, back pressure is greater than or equal to the critical pressure ratio, then convergent nozzles are used. Divergent, when back pressure is less than the critical pressure ratio, then divergent nozzles are used. That also you mentioned. Critical pressure ratio means what? That also you mentioned. Throat means what? That also you mentioned. So generally we are using many industrial applications using convergent divergent type of nozzles. So many times they are going to ask the MCQs convergent nozzle, divergent nozzle, that back pressure, that definitions are over, Asmita. Definitions. These slide diagrams are over only. Others, please reply. Diagrams over. So okay. All please reply so that I will use some time to write definition also. Okay. So we'll go to definition part. Write down definitions. Okay. So as per the request of Jagannath Authority, critical pressure ratio is the pressure ratio where we can get the maximum mass flow rate. Means where the velocity is maximum. So maximum mass flow rate means what? Mass flow rate, for that we are responsible. Mass flow rate means what? It is area into velocity. Is nothing but what? That product we call it as mass flow rate. So critical pressure ratio is that pressure ratio where we can get the maximum mass flow rate. So that pressure ratio is called as. So in the nozzle, so in it is pressure or the pressure. It is a ratio. Inlet pressure is denominator quantity. The pressure at which we can get maximum velocity or maximum mass flow rate. So that pressure or that pressure ratio is called as critical pressure ratio. Understood? Pressure in the nozzle wherever we are getting. So generally at the throat where the area is minimum, जिथे area minimum आहे तिथे velocity जास्त असते, so mass fluid काय असतो जास्त, त्या प्रेशरला त्या प्रेशर that pressure is called as critical pressure. म्हणजे that pressure divided by inlet pressure, initial pressure, so it is called as critical pressure ratio. Understand, Jagannath? Please reply. Okay. Okay, thank you. Others, please reply so that I will go ahead. Oh, Abhijit. Okay. Okay. Now we have to discuss about now here flow of steam through nozzle. Whether we are getting Asmita this slide, flow of steam through nozzle. News presentation I have opened. Is it visible that flow of steam through nozzle, that slide? Okay. So now we are how we are going to how the steam is flowing through nozzle. That mathematical expression we are going to learn now. Now, the first of all, remember that the expansion of steam through nozzle is considered as adiabatic. Adiabatic means what? Isentropic. So you will know that it is adiabatic, or you can say isentropic means entropy is remaining constant. So isentropic, adiabatic or isentropic. Okay. Then the steam has a very high velocity at the end of expansion, and the steam has very high velocity at the end of expansion. So even because all pressure energies get converted into velocity, the steam is having high velocity at the end of expansion, and enthalpy decreases as expansion here starts. So we are having this particular diagram, HS diagram. So enthalpy versus entropy diagram. So for the steam, generally we are following which diagrams? Enthalpy versus entropy diagram. So here, and only which part we are going to, this is a critical, this is our saturated curve, this is our critical point, Cp, okay, this is liquid line, vapor line, and only this expansion, this is, let's consider this as a boiler pressure. The steam is expanding in turbine. So turbine means expansion is actually happens in nozzle only, and this expansion is isentropic, and this is a condenser pressure. Okay, so initially we assume that at point 1 the steam is entering into the nozzle, and the expansion is adiabatic. Theoretically, we say that expansion is adiabatic up to condenser pressure. Okay, let us have this enthalpy H1 when the steam is entering into nozzle, and when it is leaving, exiting from the nozzle, its enthalpy will be H2. Okay, so as the expansion is adiabatic, total energy of the steam before expansion, adiabatic म्हणजे काय तर आपण we are not going to provide energy to that particular steam, or we are not getting where external energy we are not supplying. Therefore energy after expansion and before expansion should be equal. Therefore total energy of steam at inlet of the nozzle should be equal to total energy of steam at outlet of the nozzle, and total energy of the inlet of the steam is equal to H1. So H is equal to what? It is pressure. H is equal to what? H is equal to U internal energy plus pressure volume energy. So everything will be included in the enthalpy. H is equal to U plus PV. We know that internal energy plus pressure volume energy. Therefore, the total energy of the steam at the inlet of the nozzle is equal to H1 plus this steam is moving with some velocity. It is having a velocity. Let us consider C1 is the velocity of the steam. Now velocity we are denoting in the chapter by letter C. Okay, so C1 is the initial velocity of the steam or inlet at the entrance, or velocity of the steam at the entrance, C1. So as we are considering specific mass, H1 means specific enthalpy, mass is equal to 1. So kinetic energy will be equal to C1 square divided by 2. Okay, and similarly H2, that is specific enthalpy of the steam at exit, H2 plus C2 square, the exit velocity, kinetic energy at exit. So it will, H will include everything, U plus PV. Okay, where H1 is specific enthalpy of steam at inlet, and C1 is equal to velocity of steam at inlet or entrance, or inlet or entrance of nozzle in meter per second. Up till this, everybody understand? Very simple. You have to record this, you have to note down this. If anybody have doubt, you can ask. So expansion is taking place. Whatever the expansion where up till now we're discussing, that is in the turbine expansion, isentropic, that expansion actually happens in the steam nozzle. Okay, so up till now everybody having problem. So this H1 enthalpy of the steam entering, so it is having kinetic energy as well as some specific enthalpy. So H1 is always, your expansion technique, H1 is always greater than H2, and C1 is always lesser than, because this H is converting into C2. Understood? Please reply. Once again I have to repeat. Understood, Asmita. Others please reply. Asmita Sarvade understood. Others please reply. The expansion of the steam through nozzle is considered as adiabatic. Okay. So as expansion is adiabatic or isentropic, so total energy of steam at inlet and outlet should be equal. And total energy of the steam at inlet will be equal to enthalpy, specific enthalpy of steam at inlet H1 plus kinetic energy. Kinetic energy, because mass we are considering as a 1. Specific mass is equal to M is equal to 1. So M V square divided by 2, 1/2. Kinetic energy is equal to 1/2 M square. So but M is equal to 1. Then we were replacing by C. So C1 square divided by 2. H1 plus C1 square divided by 2. is equal to H2 plus C2 square divided by 2. Everybody understand? Please reply. Only Asmita is understanding. Others, please reply. I repeat it again. Please reply so that I will get confident so that we to move ahead. Prerna one can understood. Okay. Others, please reply so that some of the representative I get that they are understanding. Okay, Vijay Bhad understood. Okay. No, no problem. Now you write down this. Draw this flow, make flow of steam through nozzle. Draw the figure also. H1 boiler pressure, condenser pressure. This is a condenser pressure. This is boiler pressure. 1 to 2 H1. This is critical point. Okay, this is HS diagram. Draw this and at least you will draw some important points and tell me over because this is very important. Is fast. Mr. over others, please reply. Asmin is already completed. Vijay Bahar, Prerna Wankhede, please reply if it is over. Others, please reply one or two representative from voice. Then we'll proceed to next page. For the derivations, if I repeat, read, then it will not understandable. So if you write, if you once through, it will go through by writing. So definitely it is easy to understand. Or you can understand. Otherwise, it is volatile. Yes. At initially, we feel that we are understanding, we are understanding, but we are. If you are not writing, then will exactly will not understand. So we'll move around the bush. Whoever Jagannath out today, Vijay Bahad, somebody can tell me that I put it to the next page. Okay. Now here we have replied that. Okay, Jagannath, yes, sir. Thank you, Jagannath. So H1 is equal to specific enthalpy of steam at inlet. C1 is velocity of steam at inlet or entrance of nozzle. Similarly, H2 is specific enthalpy of steam at outlet of nozzle, kilojoule per kg, or velocity of steam at exit in meter per second. So, okay. Now here C2 square, if you go for that, again I will write here C1, here what all the equation, H1, I will write here H1 plus C1 square divided by 2 is equal to, that was the previous H2 plus C2 square square. Okay, therefore C2 square minus C1 square, because C2 is higher than C1. So C2 square minus C1 square divided by 2 is equal to H1 minus H2. Okay. Now here henceforth we have to here concentrate. Now C1 and C2 are in meter per second. So C1 and C2 are in meter per second, and H1 and H2 are kilojoule per kg. So even we want to make units are always balanced. Okay, dimensions are balanced at both sides. So when we want to make it is in joule per kg. So SI unit of heat is joule per kg. Okay, so to make it in joule per kg, it is kilojoule per kg. We have to multiply it by 1000 so that to manage to have the SI units on the both sides. So C2 square minus C1 square divided by 2 is equal to 1000 into H1 minus H2, where H1 and H2 are in kilojoule per kg, and we have converted into joule per kg by multiplying it by 1000. Everybody understand this step? Please mention. Please mention. Very important step. Because we are taking H1 and H2 always in kilojoule per kg as per the steam table calculations. Yes, sir. Okay. Asmita, other please reply. Yes, sir. Others please reply. So this step is very important. Okay. So okay. Thank you, Vishal. Thank you, Prerna. So therefore, C2 square, this is now remember that C2 is in C2 and C1 is in meter per second. H1 and H2 are in always in kilojoule per kg. Therefore, we have taken multiplying factor as a 1000. Okay. Therefore, C2 square minus C1 square is equal to 2 into 1000. So 2000 into H1 minus H2, or C2 square, it is the exit velocity square, is equal to 2000 into H1 minus H2 plus this C1 square. Okay. Therefore, C2 is equal to 2000 into H1 minus H2 plus C1 square. And therefore, 2000 into HD. So H1 minus H2 also we can call it as a enthalpy drop of steam in nozzle, that is HD, and is equal to H1 minus HD. So therefore, 2000 into HD plus C1 square. Okay. If C1 is not given in the numerical, okay, then but initial velocity of steam is very less. आता ह्याच्यात कसं असते, C2 हा एवढा जास्त असतो C1 पेक्षा की C1 is negligible. C1 can be neglected as compared to C2. Therefore, initial velocity of steam is very less as compared to exit velocity of steam. Hence, neglecting C1, or you can say that C1 is too much smaller than C2. Neglecting C1 म्हणजे काय होणार, फक्त C2 is equal to 2000 into C2 is square root of 2000 into HD, or C2 is equal to for 2000 square root काय येतो 44.72 into square root of HD. HD is equal to enthalpy drop in nozzle, or C2 is equal to 44.72 into square root of H1 minus H2. Understand? Please reply. Shall I once again explain? So once again I will explain. Specific enthalpy of steam of here of at outlet of nozzle. C2 is equal to velocity of steam at exit. Okay, both are in meter per second, and H1 and H2 are in kilojoule per kg. Hence, but to have the SI unit on both sides here, H1 and H2 should be also in joule per kg. And to have this, we have multiplied this kilojoule per kg quantity by 1000, means we are converting into joule per kg, multiplying factor. So therefore, C2 square minus C1 square is equal to 2000 into H1 minus H2. Okay, C2, we want C2 exit velocity, kinetic energy of steam at exit. C2 square is equal to 2000 into H1 minus H2, and this C1 will go to this RHS side, it will become C1 square, and C2 will become square root of 2000 into H1 minus H2 plus C1 square, or this H1 minus H2 now henceforth we are called as a HD, this is the enthalpy drop. Therefore, C2 is equal to square root of 2000 into HD plus C1 square. Okay. Now, if this C1 is too much lesser than C2, म्हणजे एकदम C1 एकदम कमी असते आणि C2 एकदम जास्त असते, त्यामुळे we can neglect C1 as compared with C2, and therefore C2 is equal to square root of 2000 into HD, or 2000 square root काय येतो 44.72 into square root of HD, or 44, C2 is equal to what here HD म्हणजे काय, तर तुम्हाला रिप्लेस करायचं नसेल तर 44.72 into square root of H1 minus H2. त्याच्यामध्ये काय C2 is in meter per second, H1 and H2 are in kilojoule per kg. Understand? Please reply. And you have to write also each and every step here. Okay, Asmita Sarvadi, yes, sir, understood. We shall understand. Jagannath understand. Please, okay, thank you. Thank you all. And please write down all this thing, and every step, each and every word you write down. Every step you write down in your notebook. Let us start with slowly, because without writing derivations, if I will read derivations within 2 hours, one chapter can be completed. Tushar Chavan. Tusharji, we are taking lecture up to 3. Tushar Sarvade, don't give attendance now. Till 50 minutes are there. Both equations were used hence in the numerical. This is one equation. Equation number 2 we have given, and this is also. So if C1 is given, then this equation C2 is equal to square root of 2000 into H1 minus H2 plus C1 square. And if only C1 is not given, only they ask the exit velocity and enthalpy drop, so we are knowing, and C2 is equal to 44.72 into square root of H1 minus H2. Oh, okay. Asmita, or other please reply. Okay, Prerna, others please. So, given all representatives. Now, up till now, we are considering without friction. That is ideal condition, theoretical condition we were discussing. Now we'll discuss one condition, that is flow of steam through nozzle considering friction. Okay, so up till now we have not discussed about the friction because we have considered ideal isentropic drop or theoretical enthalpy drop. So write down now flow of steam through nozzle considering friction. Considering friction. Now here also we'll let us consider this ATD diagram first. Already it is drawn there. Still this faint HS. This is our saturated curve, only we are interested in nozzle part. So this is, let us consider this as a boiler pressure. Okay, let's consider this as a condenser pressure. Now if one point we are considering 1 to 2 as a isentropy enthalpy drop. Okay, but we know that in actual Rankine cycles we have discovered there is a friction present in between this particular turbine, okay, turbine parts and steam. Therefore, this expansion will not be isentropic. This expansion will be unisentropic. And therefore, this point number 2 will have to replace by H2 dash. Okay, and this is theoretical enthalpy drop will be here in this case. Theoretical enthalpy drop. Theoretical enthalpy drop is equal to what? Theoretical without friction is equal to H1 minus H2. And here actual enthalpy drop due to friction will be what? Actual enthalpy drop. What will be, anybody? Actually enthalpy drop or HD dash म्हणू शकतो आपण is equal to H1 minus H2 dash. Definitely H1 minus H2 dash is smaller than H1 minus H2. म्हणजे ड्यू टू फ्रिक्शन वेलोसिटी काय होईल, डिक्रीज होईल का काय होईल? Due to friction, enthalpy of steam increases. फ्रिक्शनमुळे एन्थाल्पी काय होते H2 डॅश H असा व्हर्टिकल आहे त्यामुळे H2 डॅश काय होईल एन्थाल्पी ऑफ स्टीम डिक्रीजेस. ओके एंट्रॉपी काय होईल एंट्रॉपी ऑफ स्टीम here it will be also इकडे जातो 2 पॉइंट म्हणजे एंट्रॉपी also increases. अवेलेबल एनर्जी ऑफ स्टीम डिक्रीजेस म्हणजे पण अवेलेबल एनर्जी काय असणार आहे ड्रॉप H1 minus H2 dash it will goes on decreasing and actual enthalpy drop becomes smaller than a theoretical enthalpy drop and hence velocity of steam also goes on. Anybody काय velocity बघा फक्त मॅथमॅटिकल ह्या एक्सप्रेशन वरून ह्या डायग्राम वरून आपण वी टू कन्क्लूड enthalpy of steam increases 2 point च्या वर जातो 2 dash point therefore enthalpy increases entropy also increases available energy म्हणजे entropy drop decreases. Okay actually enthalpy drop becomes smaller than decreases smaller than theoretical enthalpy drop hence here velocity will be also goes on decreasing. So this is the friction exists between the nozzle surface and steam. Due to this, sum of enthalpy of steam decreases to overcome friction. Also, okay, due to friction present, so enthalpy drop, not the sum of enthalpy drop. Okay, and due to friction process, expansion will not be isentropic; it will be anisentropic. And the effect of friction will be what? Enthalpy of steam decreases, entropy of steam increases. Enthalpy of steam increases, entropy of steam increases, available energy here it is decreases. Here actual enthalpy drop becomes smaller than theoretical enthalpy drop, and actual enthalpy drop H1 minus H2 dash is smaller than theoretical enthalpy drop H1 minus H2 due to friction. Okay, and due to that and this nozzle efficiency, now we are denoting by letter K. But how we define nozzle efficiency? Here, nozzle efficiency is defined as ratio of actual enthalpy drop in the nozzle to theoretical, because efficiency should be always less than 1. Okay, and actual enthalpy drop divided by theoretical enthalpy drop, and is called as K is equal to H1 minus H2 dash divided by H1 minus H2, or actual enthalpy drop will be equal to K into bracket H1 minus H2. Understood up till now this? Anybody having problem? What happens due to friction? Everything is explained by me 2 times. Still anybody having doubt, you can ask. This is called as flow of steam through nozzle considering friction. Understand? Nobody is replying. I don't know why. Okay, Asmita may be understanding. Asmita, Prerna, okay, thank you. And write down. Others, please reply. If doubts are there, please ask. Draw this everything, each and every. Okay, Vishal Metkari understood. Vishal Jagannath Avtade, please reply. Good, very good, Vishal. Please write all these things. Vijay Bad, okay, Vijay, thank you. So we don't. So we will what? Don't give attention now. Write down everything. Whatever I am. It shows that you are not interested in lecture, only interested in giving attendance.
सर
Ah,
एक डाऊट होता.
yeah, you can. Oh.
फर्स्ट पॅराग्राफ मध्ये तिथं लिहिलंय की एंथॅल्पी ऑफ स्टीम डिक्रीजेस टू ओव्हरकम फ्रिक्शन.
एंथॅल्पी ड्रॉप म्हणतो एंथॅल्पी ड्रॉप.
पण खाली तिथे जे फर्स्ट पॉइंट लिहिलंय ना तिथे एंथॅल्पी ऑफ स्टीम इन्क्रीजेस असं कसं.
आता एंथॅल्पी ड्रॉप म्हणजे काय तर H1 - H2 काय आणि एंथॅल्पी ड्रॉप म्हणजे H1 - H2 आणि एंथॅल्पी इन्क्रीज का होतं फ्रिक्शन मुळे हीट अजून काय होणार त्या स्टीम मध्ये हीट होईल काय होणार गेन होणार ना स्टीम मध्ये फ्रिक्शन झाल्यामुळे. एंथॅल्पी म्हणजे काय एक प्रकारची हीटच आहे आणि स्टीमचं फ्रिक्शन झालं त्या सरफेसची त्याच्यातली जी हीट काय होणार गेन होणार आणि आउटपुट एंथॅल्पी काय होणार त्याची वाढणार. इथं आपण एच डायग्राम बघितलं पण एच डायग्रामला 2 पॉईंट इथं आहे आणि फ्रिक्शन मुळे जर 2 पॉईंट काय होतो या प्रेशर लाईन अशा आहेत इन्क्लाइंड आहे तर 2 पॉईंट हा शिफ्ट होतो असा इन्क्लाइंड लाईनला. त्यामुळे एच व्हर्टिकलला 2 हा 2 डॅश हायर लेवलला असणार इलिव्हेशनला असणार आहे. त्यामुळे एंथॅल्पी काय असणार आहे 2 ची 2 डॅश जास्त असणार आहे कारण हीट त्यामध्ये ऍड झालेली आहे फ्रिक्शनची. पण आपल्याला एंथॅल्पी ड्रॉप पाहिजे आपल्याला H1 - H2 तो ड्रॉप मात्र काय होतो व्हर्टिकल ड्रॉप व्हर्टिकल डिस्टन्स हे काय होतं कमी होतं. समजलं लक्षात आलं.
हा सर समजलं.
एंथॅल्पी ड्रॉप कमी होतोय पण एंथॅल्पी त्याची काय होते वाढते म्हणून तर एंथॅल्पी ड्रॉप कमी होतो. अंडरस्टँड क्लिअर झालं का नाही का आपलं जगन्नाथ ना.
हा सर कळालं.
ओके. Completed. Yes sir, over. Other please reply fast. No one could over. Jagannath, Vishal, somebody can reply. Over sir. Ganesh, thank you Ganesh. Okay, nozzle efficiency K. You define nozzle efficiency now. Nozzle efficiency already were defined. So write down this also up to this. So nozzle efficiency we have defined as it is the ratio of actual enthalpy drop to the theoretical enthalpy drop. And this nozzle efficiency may be 0.85 or sometimes it is friction loss. They are giving 0.15. So nozzle efficiency will be what? 1 minus 0.15. So it will be 0.85. Sometimes they will give nozzle efficiency as 0.85, or sometimes they will give loss of energy is 15%. So in that case, nozzle efficiency will be 1 minus 0.15. 15% means 0.15. In that case, 0.85. So nozzle efficiency defined as ratio. So up to this, write down and tell me over. Up to this. Others please reply. Then okay, so now the actually enthalpy drop is coming as h1 minus h2 dash, and is equal to what? K into bracket h1 minus h2. Now since from this, let us consider we want to find out the actual exit velocity, the c2 dash we want to find out. And how to find out from this? And if we know the h1 minus h2, so the actual exit velocity by neglecting initial velocity is given by c2 dash is equal to 2000 into hd dash, because it is actual enthalpy drop. But we know that actual enthalpy drop hd dash is equal to k into bracket h1 into hd dash is equal to h1 minus h2 dash actual enthalpy drop, or is equal to what? c2 dash is equal to 2000 into h1 minus h2 dash, or but is equal to k into h1 minus h2. Therefore c2 dash is equal to 2000 into k into h1 minus h2. So if we want to find out actual enthalpy drop, and if we know the nozzle efficiency, then it is equal to 2000 into k into h1 minus h2, or in bracket here 44.72 into k into hd. If 15% enthalpy drop occurs in the nozzle in the form of losses, then like friction, then nozzle efficiency should be considered as 0.85. म्हणजे कधी कधी nozzle efficiency डायरेक्ट देतात 0.85 वगैरे, आणि कधी कधी ते 15% लॉस म्हणतात, तर त्याच्यातून 1 minus 0.15 म्हणजे 0.85. Everybody understand now this actual exit velocity? So actual exit velocity म्हणजे काय? 2000 by neglecting, this is very important, by neglecting initial velocity, c2 dash is equal to square root of 2000 into hd dash, but hd dash is equal to by actual enthalpy drop, it is h1 minus h2 dash. Okay, therefore c2 dash is equal to 2000 into h1 minus h2 dash, but h1 minus h2 dash is equal to by nozzle efficiency k into h1 minus h2. Therefore c2 square, c2 dash is equal to 2000 into k into h1 minus h2, or 2044 into k in 44.72 square root by into square root of k into hd, k into hd. Understand? Only mathematical adjustments are there and initial formulas. Understand? Please mention understand and complete this. Or I can write c2 dash is equal to dash is equal to 44 0.72 into square root of k into hd, or c2 dash is 0.72 into square root of k into h1 minus h2. Anybody doubt? Understood, sir. Okay. So write down. So all these formulas are useful in the calculations in solving numericals. Write up over, please reply. Submit over. Sir, what is K in the formula C2? K is here, nozzle efficiency. Prerna. Already we defined nozzle efficiency. H1 minus H2 dash is equal to K into, by definition, K is equal to actual enthalpy drop divided by theoretical enthalpy drop, and K is equal to H1 minus H2 dash divided by H1 minus H2. Therefore, actual enthalpy drop H1 minus H2 dash is equal to K into H1 minus H2. Understood, Prerna? Okay, thank you. Okay, only Asmita's I think write up is over. Prerna, write up. Others please reply. Over. Ganesh, Jodi, over. Now we have to calculate. So this also you wrote down. If 15% enthalpy drop occurs in the nozzle in the form of losses, then nozzle efficiency should be considered as 0.85. If 20% it is there, it is, we have to consider it as a 0.80. So 1 minus that losses, or sometimes they will directly give the nozzle efficiency as 0.85, 0.90, 0.80. Generally, nozzle efficiency is 0.85. Generally. And after writing this, give heading also. This is discharge. This is very important derivations. Is asking if offline examination. So discharge through, this is very big derivation. You might discharge through nozzle or condition for maximum discharge. Discharge through nozzle or condition for maximum discharge. After writing this, please tell me over and we'll write down. Consider so I'll explain. Over. Okay. Others please reply. Please reply fast. Now for this, we have to consider now discharge. How much discharge is flowing through the nozzle is very much important aspect. Okay, and at the same time, pressure ratio is also very important. So nozzle should have maximum mass flow rate, maximum velocity, and at the same time, its pressure ratio should be also maintained. So for getting this derivation related to discharge and condition for maximum discharge, we are considering a convergent divergent nozzle. What is that? We are having three types of nozzle. Out of that, we are considering a convergent divergent type of nozzle. So convergent divergent nozzle means what? This will be inlet section. Okay. This will be so this will be convergent inlet. Okay. This is convergent part where the diameter or area is minimum. So that part we are calling as a throat. And afterwards what? This will be divergent outlet. This is convergent divergent nozzle we are considering. So this will be outlet. So we can call outlet or exit. This will be inlet. The steam is coming from this left to right direction. This will be inlet, we can say. Okay. Let us consider P1 is the pressure, initial pressure at inlet P1. Specific volume will be V1. Let us consider steam velocity will be C1 and H1. Okay. And similarly, at throat, this will be throat section. So inlet, throat, and outlet, or it is convergent section. Convergent, I will write here convergent CON, and this will be divergent part. And at throat, where the pressure will be P2, where pressure is decreasing very fast, as center of expansion. Specific volume will be V2, and velocity will be C2. Understand this figure? So the steam is entering from left to right direction. It is inlet, entering into convergent section. At throat, the pressure will become very less. Okay. Then velocity will become maximum C2. Its specific volume will become V2, and then divergent part. Okay. Then let us consider then let P1 is equal to pressure of steam at inlet. V1 is equal to specific volume of steam at inlet. C1 is equal to initial velocity of steam at inlet. P2 is pressure of steam at throat. V2 is specific volume of steam at throat. C2 is velocity of steam at throat, and A2 is area of cross section at throat. Okay, so everybody understand this figure? Nomenclature. Let us we'll find one by one. We'll go. Otherwise, derivation is too much big. If I will read or I will explain you, and I will ask, if I will ask you to write again in a little bit, we will one part will explain. We'll write down. Then we'll go ahead. That will be okay. Asmita, others please reply. I think nothing is in that. The only diagram I will write down. Yes, sir. Okay. So draw this and nomenclature. So big derivation today we could not come. I don't know. We will not complete. We'll at least 15 to 20, 15 to 20% part of the derivation will complete today. That tomorrow we will complete. Tomorrow next class, whatever is the class. I think timetable is changed. I think, am I right? Little bit variation. They have morning lecture. They have cancelled hours. All lecture they have kept in evening. Request CC to have the lectures of thermodynamics at least in morning one slot or earlier. I will also request. Write down this, draw figure and write down, and then write down. Give me message, reply. Or sir, very good. Others please reply like Jagannath, one or two representatives, so that I will move to next page. Asmita, it is over. Diagram and explanation. Prerna one today, please reply. Yes, yes, sir. Okay. Now the expansion is adiabatic, and adiabatic law is what? PV raised to n is equal to constant. So this is very important. So whatever the adiabatic expansion is there, it is following the law. That is PV raised to n is equal to constant. This is very important. So adiabatic law is PV raised to n is equal to constant, and n is equal to, now this n is given by this value of the type of steam. So this n is equal to 1.3 for superheated steam. So in MCQ they are going to ask. So PV raised to n is equal to constant. So n is equal to 1.3 for superheated steam. N is equal to 1.135 for dry and saturated steam. These values of n they have found out experimentally. And n is equal to 1.035 plus 0.1x for wet steam. And this equation is derived by scientist, or this formula is here derived by scientist Jenner. Then it is called as what? Jenner's equation. Okay. So as the law of expansion is adiabatic, therefore it is what? It is follow the law. PV raised to n is equal to constant, and this n is equal to 1.3 for superheated steam, n is equal to 1.135 for dry and saturated steam, and n is equal to 1.035 plus 0.1x for wet steam. Okay, write down up to. And now as expansion is adiabatic, okay, then gain of kinetic energy of steam is equal to here work done by steam in the nozzle. So whatever the steam is gaining the kinetic energy is nothing but what? Work done by steam in nozzle. So therefore by adiabatic expansion means we are getting the work done by steam in nozzle is equal to gain in kinetic energy, and therefore gain in kinetic energy is equal to what? C2 square minus C1 square divided by 2 is equal to adiabatic law, expansion law, where work done in adiabatic expansion is given by the formula. So this formula you all learned in BME, n upon n minus 1, P1 V1 minus P2 V2, or work done in adiabatic process is given by n upon n minus 1, P1 V1 minus P2 V2, where n is what? Adiabatic index. PV raised to n is equal to n. It is n, it depends on which kind of steam it is. Okay. As we know that C1, let us consider C1 neglecting C1. C1 is too much smaller than C2. Therefore, neglecting C1. So what we are getting? C2 square by 2 is equal to n upon n minus 1, P1 V1 minus P2 V2. And therefore, C2 square divided by 2 is equal to n upon n minus 1, P1 V1 into bracket, P1 V1 the common card 1 minus P2 V2 upon P1 V1, or P1 V1 raised to constant. Therefore, P1 V1 raised to n is equal to P2 V2 raised to n. Therefore, V2 upon V1 raised to n is equal to P1 upon P2, or P2 upon V1 raised to n is equal to P2 upon P1 raised to minus 1. And here the value आपण put up केली तर काय येणार इथं P1 n upon n minus 1 P1 V1 into bracket 1 minus P2 upon P1 into P2 upon P1 raised to minus 1. So therefore, V2 upon V1 is equal to P2 upon P1 raised to minus 1 upon n. Therefore, C2 square upon 2 is equal to n upon n minus 1 P1 V1. Okay, in bracket 1 minus P2 upon P1 into P2 upon P1 raised to 1 minus 1 upon n. And here काय येणार C2 square upon 2 is equal to n upon n minus 1 P1 V1 into bracket 1 minus P2 upon P1 raised to, आता यात काय येणार n minus 1 upon n. याचं जर सिम्प्लिफिकेशन केलं तर काय येणार 1, okay, minus 1 upon n. It will be what? n minus 1 upon n. Therefore, C2 square upon C2 square is equal to 2 into n upon n minus 1 into P1 V1 into bracket, okay, काय नाही होत 2 इकडे घेतला आपण, 1 minus P2 upon P1 raised to n minus 1 upon n. And therefore, C2 is equal to square root of 2 into n upon n minus 1 P1 V1 into bracket 1 minus P2 upon P1 raised to n minus 1. So from this equation one can find out velocity of steam at float. So आतापर्यंत आपण हे बघत होतो. आता आपल्याला जर प्रेशर रेशो माहित असतील, n व्हॅल्यू माहित असेल तर कसे फाइंड आउट करायचे ह्या डेरिवेशन्स. वी आर गोइंग टू दॅट डेरिवेशन्स. Once again I will repeat. So adiabatic expansion, it is following the law. Adiabatic expansion, that is PV raised to n is equal to constant, because we are assuming that expansion of steam through nozzle is adiabatic. It is following the law PV raised to n is equal to constant. N value depends on quality of steam, type of steam. N is equal to 1.3 for superheated steam. N is equal to 1.135 for dry and saturated steam. N is equal to 1.035 plus 0.1 into x. So this is for wet steam, and this equation is derived by Jenner. Hence it is called a Jenner's equation. So MCQ they will ask this question. As expansion is adiabatic, so gain in kinetic energy of steam is equal to work done by steam in nozzle, because expansion we are getting work done, आणि वर्क डन झाल्यामुळे स्टीम मध्ये काय होते गेन इन कायनेटिक एनर्जी. सो गेन इन कायनेटिक एनर्जी दॅट इज C2 स्क्वेअर minus C1 स्क्वेअर upon 2, because specific mass we are considering, is equal to पॉलिट्रॉपिक एडियाबॅटिक प्रोसेस मध्ये जर वर्क डन जर फाइंड आउट करायचं असेल तर बीएमए मध्ये शिकलेलं फॉर्म्युला काय n upon n minus 1 into bracket P1 V1 minus P2 V2. As C1 is too much smaller than C2, therefore what we can say here, neglecting C1, C2 square divided by 2 is equal to n upon n minus 1 into P1 V1 minus P2 V2. Now we can relation, we are having this relation, C2 square divided by 2 is equal to n upon n minus 1 P1 V1. सगळे सेल्फ एक्सप्लेनेटरी मी प्रत्येक स्टेप एक्सप्लेन केले दिलेले आहे व्यवस्थित घेऊन. तर 1 minus P2 कॉमन काढला, P2 V2 upon P1. आता V2 upon V1 म्हणजे आपला लॉ काय, PV raised to n is equal to constant. Therefore P1 into V1 raised to n is equal to P2 into V2 raised to n, and therefore V2 upon V1 raised to n is equal to P2 upon P1. Therefore V2 upon V1 raised to n is equal to P2 upon P1 raised to minus 1. Therefore V2 upon V1 is the square putting as a P2 upon P1 raised to minus 1 upon n. Either put up the C2 square upon 2 is equal to n upon n minus 1 is P1 V1 into bracket 1 minus P2 upon P1 raised into P2 upon P1 raised to minus 1 upon n. Therefore C2 square upon 2 is equal to n upon n minus 1 P1 V1 1 minus P2 upon P1 raised to simplification n minus 1 upon n, or c2 square is equal to 2 इकडे घेतलं, c2 is equal to square root of 2n upon n minus 1, p1 into bracket 1 minus p2 upon p1 raised to n minus 1 upon n. And from this equation, c2 means what? Exit velocity or velocity of steam at throat. कशाचे? Throat किंवा just velocity असलेली. आपल्या maximum velocity म्हणजे just velocity, c2 velocity at throat we can find out. Understood? Up to this, I think up to this only today will complete. You write down to understand. I think only thing is there that this equation we have to remember from BME, okay, and afterwards some adjustments. I think understood, sir. Okay, thank you, Asmita. Others please reply and write down up to that. So this only up to velocity derivation will complete today, and next part will. Others please reply. Anybody have doubt? Voice side, nobody is replying. If any doubt is there, please ask me. If I will explain derivations, all things, all steps I have, when I was taking derivation in the class, I have given in all steps. Therefore, only I have to read the derivation. So we will complete that topic in 2 hours also. Therefore, I am asking you to write down so that if it makes practice, you will make perfect in derivations. Writing is important. Practice is important in kind of derivation, talents. Others, girls, boy students, reply fast. Others are not replying, only they are attending. Write down these steps also. So this will be end of after writing up to this here velocity. This will be end of this lecture. Please reply after first page writable over. Only 3-4 steps are there. This step is very important. Gain in kinetic energy is equal to जेवढी गेन होतं ते म्हणजेच काय वर्क डन झाल्यामुळे. Smita over. Others please reply. You have to discharge equation you write down. And tell me over. So this will be end today.